Hello, today we're going to look at the capabilities of MEPro to find section properties. I'll start with a simple example, one from our textbook. It's a simple T-beam, and you can see the dimensions for the T-beam over here. I'll go ahead and start on my calculator. We got to turn it on first, okay. And I'm going to escape out of here and go back to opening screen for apps. I want to start MEPro. You should install that. It's a free application you can get from Texas Instruments. Select that by hitting enter. And hit enter one more time. Like it says, press any key to continue, or just while you're down here, press enter. And you'll have to learn this application. It's quite extensive, but the one we'll want to use is in F2 analysis. So I hit the F2 key. And number 6 is section properties, so you can either hit the 6 or toggle down. Now, we'll match the name here that we see: rectangles, circles, hollow, I-beams, and there's one more below this, so I'll scroll down. T-section, which is what we have over here. So I'll select the T-section, and it asks me for 4 dimensions. And if you don't know what those dimensions are, we can take a look at their picture and see how they're labeled. F4. It says for a T-beam, there's a B, the T is the thickness of the flange, and TW is the thickness of the web, and D is the depth from underneath the flange to the bottom. So we'll go back to continue, and now we'll enter the B dimension, which is 150 plus 150. I'm going to put in 0.3. meters is what I'm going to keep this in. Now you can turn on your meters, if your dimensions, if you want to, but I'm just going to leave it dimensionless. Well, that's already in meters there for what my calculator is set up to. I usually work these with the dimensions turned off, because I switch back and forth between them. You can actually hit 3 to toggle the units off. You see, you just get 0.3. The thickness of the flange is 50 millimeters, so you type in 0.05 for 50 millimeters, hit enter. The depth is 0.3 again for the depth, and the thickness of the web is 50.05, enter. Now that all dimensions are in, we can solve it. What we want to calculate is F2, just hit F2, and it's busy for a moment, and then gives us the information like area, YY1, YY2. Those are the distance of the centroid. If you scroll down here to YY1, you can see its distance to bottom. Be careful about that, because I'm not sure they always get their up and down right. In this case, it looks like to me it's 350 millimeters high, and that's closer to the top half than the bottom half, so I would not put it down here at around there. That's too far away. It's probably inverted. So we'll say that centroid is located at 0.125 meters from the top, or 112.5 millimeters from the top, although it says bottom. Be careful about that. The centroid other distance just takes advantage of the symmetry of the shape, and since it's 300 millimeters wide, the centroid is at the y-axis. Now, I11 is the principal axis, and I22 is the other axis. So I11 is the axis that we see here. We normally orient a T-beam with a flange at the top or the bottom, and so it would be 345.31 times 10 to the minus 6 meters to the 4th. We can also look down IY2. These are radius of gyrations, and we get all the information we need for that. So it's pretty simple. Now I'm going to show you how you can adapt it to a few other uses. I'm going to hit escape and go select one of these other ones. But first we need to change our slide. Go to this one here. This one is a unusual shape, and we don't have that as one of the shapes here. T-section, trapezoid, polygon, hollow polygon. No shape for that. But we can adapt this shape to a T-type if we pull these lower pieces together It doesn't affect the area or the location of the centroid or the moment about the y-axis. It will, however, change the moment about the about the y-axis. It doesn't affect the axis of moment of inertia about the x-axis, which is the one we're interested in for most of these kind of shapes. So if we visualize that it's this looks like this, now we got the T-beam just like we had before, so we can come down here to number 9, T-beam, and I can clear all those out as we want. And we can start at the top again. This time it's going to be 6 inches. I'll just put it in 6. Again, no units here, and you can see it turn on if I want to and convert. That's really good for mixed units. I try to keep things in base units here. T is the thickness of the flange is 2 inches. The depth is 4 inches. And the width of the flange is the 1 plus 1 here. We have to pull those two pieces together, so it's 2 inches thick. And again, we'll solve at F2. The area is 20 inches. YY1 is 2.2 inches. Again, it says it's from the bottom, but it's actually the distance to the top, just as you show on the sketch here. 2.2 is just below the junction of the web and the flange. I11 is 57.86, which is mass moment inertia. So you can see it's pretty simple to input this in, and all the information you need is right here in front of you: centroids, area moment inertia, that sort of thing. Well, let's adapt it to another one here. The last one is a problem we worked in class by hand last week, and this also is not one of the shapes we see here. What can we do? Well, the last strategy was to bring in these side pieces to the middle, and we did that. We'd have a very unusual uneven I-beam, but we could make it work. Let's see if we can make that work. Going up here to TI section uneven, number 7. Okay, for I section uneven, we need to put in the that's even. Let's go back. I section uneven, number 6. And you see a few more dimensions here. The B dimension is the top width here, which would be 3 plus a half and a half. That's 4 inches. So I just type in 4 here. It does keep the ones from before. We can keep them if we need them. Now the thickness of the flange, I'm going to say that this is going to be the flange on the top. It's a 1/2 inch thick, so 0.5. Now the lower width of the flange, I'm going to call, when I pull these two pieces in together, they're going to be the web, and then this piece down here, which doesn't look like a flange, is going to be the bottom flange. It's going to have a B1 inches of 0.5. T1 is the thickness of the flange. Well, let's see here. It's 3 inches, 7 inches total here, 7 inches thick. The D distance, the depth of the web, is 3 inches. And the thickness of the web, I'd have to add all three of these together. So that's a 1/2 inch there, 1/2 inch there, and a 1/2 inch there, or 1.5 inches. And that's entered. Now I've got all the information. We'll hit to F2 to solve it. And we have the area, YY1, YY2. Now, YY1 in this case, since it's uneven, this says it's 7 inches to the bottom, which is the right, it's right in here at them towards the top, but not far. YY2 is it says distance from side to side. That's not right. So sometimes these labels are a little confusing. But the area is correct, 10 inches squared, and I11, the principal axis, is 91.73 inches to the 4th. Well, that shows you how you can adapt some of the built-in shapes of MEPro to solve some simple section problems using whatever you can. If you need a little help with that, see me after class. Thank you.